Welcome to the Harvard Ceramics program's Kiln Room. Here we see all the pots glazed and ready to be loaded into the kiln.
Hi, my name is Sarah, and I've just finished loading this reduction kiln, our Bailey kiln. To load a reduction kiln, you want to get as many pieces in as possible and make sure they don't touch. If they touch, when the kiln gets really hot, the glazes will attach to each other and you will have a lovely sculpture, but not what you were expecting. So we can actually put pieces quite close together, but they need to have at least paper width apart. So if you can see down this crevice here, it's very, very close, but it won't stick. If it was touching, that would be the end of it.
Great.
We also need to make sure that it's not touching the shelves above, and we have to make sure that the bottoms of the pots are clean. Sometimes people forget to wipe off the bottoms of their pots, and then we have pots attached to the shelving, which isn't a good thing either. So we're going to fire this to a temperature that's about 2300 degrees. And all these glazes were made to melt at approximately that temperature. It'll fire for about 12 hours, and then it'll cool for about a day and a half.
So we're now going to talk about cone packs, and what you're seeing here, this is the before version and this is the after version of a typical cone 10 reduction firing in one of our gas kilns. And so how cones work is that each of these cones, manufactured by the Orton Company, is a combination of ceramic materials that will melt at a specific heat. And though we don't use the actual temperatures, say for cone 04, which I know would be 1940 degrees Fahrenheit, what we do is we refer to cones in terms of numbers. So in this area right here, we may have 6, 7, 9, and 10. And so that's why we use that terminology due to these cones to call a high fire firing a cone 10 firing. Mid-range might be a cone 6 firing, and low fire for, say, terracotta or earthenware would be an 04 firing. So when we have the cones in the kiln in different areas, what that's doing is that's going to tell us not only the temperature of the kiln, but the work heat. So how hard the kiln is working and at what speed the heat is rising. So in this example here, you can see why we have to put these in these little boats or trays, because the very low fire cones that tell us what the early part of the firing is doing are essentially going to turn into glass. The cones that are here for the later part of the firing are going to tell us when we're achieving our target temperature, which would be around 2300 degrees Fahrenheit. So this cone 10 cone I can see is beginning to get soft, whereas the 9 cone has already bent all the way over and hit the next cone. So we have to make sure that these cones are visible, because it's very important that we're looking at them while the kiln is firing, and we're checking them constantly to see the rate and speed. And so this, coupled with the ability to see the temperature on the digital readout on the side of the kiln, tells us how things are going. Now, in primitive kilns, not having cones and whatnot, what potters would do are to create rings of clay that they would have inside the kiln and be able to get those rings out, say with a long stick, and plunge them into water and then observe the fragility or stability of the clay at that point of the firing, as well as the surface. So what we want to do at this point in the firing is to look inside the interior of the kiln and observe the cones. And what we're looking for is any movement of those cones to tell us that the temperature has increased. In addition to the digital reading that's on the side of the kiln, we see Sarah here needs to be constantly adjusting the combination of gas and air that is flowing into the kiln to make sure that the kiln doesn't stall and instead the heat is rising. This is what we call our kiln log for one of our cone 10 reduction gas firings. And what we have here is a chart where we're noting the time, the temperature from the digital readout inside of the kiln, as well as the air setting, the gas setting, and then our damper. And how open or closed the damper is makes a really big difference in terms of the airflow within the firing. And when we go into reduction, we close that damper to cause a less oxygen to be able to flow throughout the kiln. So here you can see we're also recording what the cones are doing. And we can see O10 is down and O6 is still standing. O6 is still standing, and then at 11:10 we see O6 is starting to curl over or to soften. So we knew that that was the time that we wanted to put the kiln into reduction. So how do we know when we're in reduction? Well, one thing we can look for is back pressure. So I'm going to open up the brick in the kiln, and hopefully you can see that amount of flame coming straight out the side there. And that is what we would refer to as back pressure. Here we're nearing the end of the firing and we're at 2262. We're looking carefully at the last two cones, cone 9 and 10. You can see the heat is much higher now. We see the damper is still in for a slight reduction and the flame coming out of the chimney is visible. Here we see Denny McLaughlin, one of our staff members, taking one last look before we shut the kiln off. Here we see the work that was fired in that cone 10 reduction kiln set out on shelving for our students to come and collect. We can see a great variety of color, oftentimes more earthy tones indicative of a reduction firing, such as browns and oatmeals, but we also see brilliant. The excitement of a reduction kiln firing is that it's very seldom that two pots are alike due to that reductive atmosphere that affects all the glazes differently. We can see a pink blush on this white cup here, which tells us it was next to another glaze that had copper in it. And note the brown speckling in the two mugs in the back from iron.